All right, so I'm looking at the rules of indices in this video. So the rules of indices are on page 21 in the formula book, so indices and logs. Right hand side is all logs. This left hand side here are the rules of indices. Okay, indices, just the plural of index, so it means powers. Okay, so like powers or index or exponent, all words you can give to this number up here. Powers we're probably more used to, but indices they tend to use a bit more often. There's 9 rules of indices listed here. They're kind of listed in abstractly, like using letters. So I'm just going to go through examples for each one just to show how they operate. The first few you will have seen before. As we go through them, they will be new. You use some more than others, but you need to know all of them. So first one here is that a to the power of p multiplied by a to the power of q is equal to a to the power of p plus q. So when you multiply the same base like this, you can add the powers together. So for example, 7 to the power of 2 multiplied by 7 to the power of 3 is equal to 7 to the power of 2 plus 3, which is equal to 7 to the power of 5. Okay, so when it's 7 to the power of something multiplied by 7 to the power of something, you can just add those powers. So if I was asked to write those as a single power, or if I was asked to write them in the form 7 to the power of n, that's how I would do it. Okay, so it is 7 to the power of 5. All right. I will go through why this is the case. So what does 7 to the power of 2 mean? It means 7 multiplied by 7. What does 7 to the power of 3 mean? It means 7 by 7 by 7. So 7 to the 2 by 7 to the 3 is equal to this. How many 7s are in multiplied together there? 5. So it's equal to 7 to the power of 5. Okay, so that second line there is just, I suppose, why the rule works, why the rule is there. It's this first line that you really need to be able to use. Okay, so how to use the actual rules. Second rule then is just the opposite of that. So when you multiply two numbers together with the same base, you can add the powers. When you divide two numbers with the same base, you can subtract the powers. So 8 to the power of 6 divided by 8 to the power of 2, that's equal to 8 to the power of 6 minus 2. 6 minus 2 is 4. So that's equal to 8 to the power of 4. Why is this the case? Well, again, what does 8 to the power of 6 mean? It means 8 by 8 by 8 by 8 by 8 by 8. So 6 8s multiplied together. Over, what's 8 squared mean? It means 8 by 8. What can you start doing then? You can cancel this 8 here with one of the 8s up the top. This 8 here with one of the 8s up the top. And how many 8s are you left with up the top then after you do your cancelling? 4. So that's equal to 8 to the power of 4. Okay, so again, this is just an explanation of the rule. This is what you need to know, that when you're dividing two things with the same base, 8 being the base there, you can subtract the powers. Third rule then, important thing here is not to get it mixed up with the first one. So when you have 9 to the power of 2 to the power of 3, you can multiply the powers. So this is equal to 9 to the power of 2 multiplied by 3, which is 9 to the power of 6. So when you have a power inside and outside the bracket like that, you can multiply the powers together. All right, so again, when you're multiplying 7 to the 2 by 7 to the 3, you can add the powers. It's when you've got the power inside and outside the bracket that you multiply the powers. So just be careful not to get those mixed up. Why does this rule hold? Again, what does 9 squared mean? It means 9 by 9. Okay, or first, well, sorry, what does power of 3 means? It means multiplied by itself 3 times. So this means 9 squared multiplied by 9 squared multiplied by 9 squared. So that's 9 squared to the power of 3. So 3 9 squareds multiplied by each other. What does each 9 squared mean? Each 9 squared means 9 by 9. So this is 9 by 9 by 9 by 9 by 9 by 9. How many 9s are there multiplied by each other? 6. How do we write that? 9 to the 6. Okay, again, this is just the explanation. It's using the actual rule you need to be able to do. Rule 4 then. So rule 4 is here. So it tells me that a to the power of 0 is equal to 1. So anything to the power of 0 is equal to 1. Okay, so you can check that on your calculator. 5 to the power of 0 is 1. 1,000 to the power of 0 is 1. Okay, so just be careful there. It's very easy in your head to go, power of 0, that's equal to 0. No, okay, power of 0 is equal to 1 always. So x to the power of 0 is equal to 1. You can even do it in algebra. So just where does this rule come from, or how can we kind of explain away this rule? Well, let's say 5 squared divided by 5 squared. So let's use rule 2 here. Okay, what's 5 to the power of 2 multiplied by, or divided by 5 to the power of 2? Well, it's equal to 5 to the power of 2 minus 2. So it's 5 to the power of something divided by 5 to the power of something. So I can subtract the powers. What's 2 minus 2? It's 0. So 5 to the power of 2 divided by 5 to the power of 2 is equal to 5 to the power of 0. Now let's go back to this. 5 to the power of 2 divided by 5 to the power of 2. What's anything divided by itself? It's equal to 1. So 5 to the power of 2 divided by 5 to the power of 2 is equal to 1. 5 to the power of 2 divided by 5 to the power of 2 is also equal to 5 to the power of 0. So 5 to the power of 0 must be equal to 1. And you could do that with any number. So any number to the power of 0 is equal to 1. All right. Into the rules now, which you're probably less familiar with. So fifth rule here, and they tell me that a to the power of minus p is equal to 1 over a to the power of p. So a negative power gives you 1 over, and then whatever you had goes on the bottom. Okay, so a negative power associated with fraction. So negative power gives you 1 over. All right, so 2 to the power of minus 1 is the same thing as the minus gives me 1 over, and then I am left with 2 to the power of 1, which is equal to 1 over 2. So 2 to the power of minus 1 is the same thing as a half. 2 to the power of minus 3 then. So again, if I want to get rid of this negative power, the negative power gives me 1 over, and then 2 to the power of 3. So it's the minus that gives you 1 over, and then you've still got left on the bottom your base and your power. So 2 to the power of 3. 2 to the power of 3 then is 8. So this is equal to 1 over 8. Last one then, 5 to the power of minus 4. And this is equal to 1 over, and then I'm left with the 5 to the power of 4. Okay, 1 over 625, I think. Yeah, 5 to the power of 4 is 625. So that is 1 over 625. All right, there are your first 5 rules. On to rules 6 to 9 then. So next up is this one here. So a to the power of 1 over q is equal to the q root of a. So most common one you will see with this is power of a half. Okay, so 9 to the power of a half is equal to the square root or the second root of 9. Okay, we don't usually write the 2 there for square root. Okay, we normally just write that. Okay, we only need to write the number when it's something else like cube root or 4 root or 5th root. Okay, but 9 to the power of a half is the square root of 9, so the second root of 9. What's the square root of 9 then? It's 3. So 9 to the power of half is the same thing as 3. 8 to the power of a third then. So when it's 1 over 3, it is the third root of 8, or the cube root of 8. So what number do I multiply by itself 3 times to give you 8? And that is 2. Okay, so you can work that out in the calculator if you need to. Next one then, 64 to the power of 1 over 4. So it's on the bottom of the fraction, so the fourth root of 64. So if you like, the 1 over is what's giving you your radical symbol, or your root symbol. And then what's on the bottom, that's what root you're getting. So second root, another way of saying square root. Third root, or another way of saying a cube root. Fourth root in this case. So what's the fourth root of 64? So for second function, this 64 is equal to, so it's 2.82. So just to pick a question like that, just pay attention to what form they want the answer in. So 2.82. Just to kind of prove this one, let's go 64 to the power of 1 over 4. And we see it's the same number. Okay, so I could just plug 64 to the power of 1 4 into the calculator, gives me that. We know it's the same thing as the fourth root of 64. So with some of these, you would be able to just kind of, I suppose, like if you put 9 to the half into the calculator, your calculator will tell you it's 3. All right, so I didn't have to go through the steps of figuring out that that means the square root of 9 is equal to 3. But you do need to be able to use the rules, okay? You might kind of get it in an algebra question where you can't use the calculator, or you might have, they might want the answer in a particular form where you need to be able to use the rules, okay? So even if some of them you are going to maybe able to jump and use the calculator rather than the rule, just practice using the rules because you need to be able to use them. Number 7 then is just kind of related to this rule here. So a to the p over q is equal to the q root of a to the power of p. So it's a little bit related to this one here, okay? So 5 to the power of 2 over 3. So the over 3 is giving me the cube root of 5. And then the 2 on top means it's all going to be squared, okay? Or you're also able to kind of write, you can also write it as the cube root of 5 squared. So it doesn't matter if you're going to square 5 first and then get the cube root, or get the cube root first and square it, you would still get the same answer, and you see it's written here both ways, okay? So it's this rule again, but this time when I've got a number on top, I will raise everything to that power. So 7 to the power of 4 over 5, that will be equal to, so the over 5 gives me the fifth root of 7, and that is all to the power of 4. Okay, you can write it like that, or you can write it as the fifth root of 7 to the power of 4, same thing. I'll work this one out then. So 27 to the power of 2 over 3. This is equal to the cube root of 27, all to be squared. So I'll try and figure this one out without a calculator. So I can rewrite it like this. So I could square the 27 first and then try and get the cube root of that. That's going to be difficult, I would say. 27 squared would be a really big number, and I'd be trying to think what's the cube root of it. So let's do it as it's written here first. Let's do the cube root first. So what number multiplied by itself 3 times is 27? That's 3. So 3 by 3 by 3 is 27. So this bit inside the bracket, the cube root of 27, that's equal to 3. So this is equal to 3 squared, and then 3 squared is 9. Okay, so I was able to do that without using a calculator. As I said, if I had kind of tried to do this bit here first, the 27 squared first, and then get the cube root, that would have been very tricky to do in my head. But 9 is the answer for that one. Again, as I'm kind of saying to you, like if you do 27 to the power of 2 over 3 on the calculator, you can see it is equal to 9, okay? And you will be able to use calculator for some of them, but sometimes you will need to use the rules depending on how they phrase the question. Rule 8 then So it's over here then. So just AB to the power of P is equal to A to the P multiplied by B to the P. So A multiplied by B all to the power of P is the same thing as A to the power of P multiplied by B to the power of P. So you can raise both things to the power and then multiply them by each other. So for example here, this one's quite handy in algebra, or else maybe here with a surd or a square root. So I've got 3 root 2 to the power of 2. Okay, so I've got 3 root 2 means 3 multiplied by root 2. So it's like the A multiplied by B here. So what I can do is write it as 3 squared multiplied by the square root of 2 squared. Okay, so the squared, when these two things inside the bracket are multiplied by each other, the squared belongs to both of them. You square both of them. All right, so 3 squared multiplied by root 2 squared. What's 3 squared? It's 9. What's the square root of 2 squared? Well, the square root and the squared cancel each other, so you're just left with 2. 9 multiplied by 2 then is 18. All right. 5x to the power of 2, so this comes up in algebra a lot as well. So 5x all to the power of 2. You square both of them. So it will be 5 squared multiplied by x squared. 5 squared is 25. So 25 x squared. All right. So people sometimes when they get that have a tendency to just say, oh, that's equal to 5x squared. All right, so don't forget, if it's all in brackets like that and squared, you square both the 5 and the x. This one here, then 2a to the power of 3, without going through the step of writing this out like this, 2a all to be cubed is equal to 2 cubed, which is equal to 8a cubed. Okay, so all the same thing. So 2a all to be cubed is 2 cubed a cubed, and it's also equal to 8a cubed. The last rule then is just very, very closely related to rule 8. So a over b to the power of p is equal to a to the power of p, b to the power of p. So if you have a fraction all raised to some power, the power belongs to the top and the bottom of the fraction. So you raise both the top and the bottom to the power. So for example, a half to the power of 3, that's equal to 1 to the power of 3 over 2 to the power of 3. So 1 to the power of 3 is 1, 2 to the power of 3 is 8. So a half cubed is 1/8. 3/4 squared then, so 3 over 4 squared. So the squared belongs to top and bottom if you're going to work this out. So that's equal to 3 squared over 4 squared. 3 squared is 9, 4 squared is 16. So 3/4 squared is 9 over 16. All right, so there's your 9 rules of indices. As I said, you will use some more than others, but you'll be able to use your kind of calculator to kind of work around needing the rules sometimes, but you do need to know all of these rules, and you will use them all the way up to Leaving Cert.